Hello, welcome back to the second video of Brain of a Penguin's YouTube channel. Today, I'm at my lake, my nice lake with an igloo. But enough about me, you came here to learn about reciprocals, so let's get into the video. So, what are reciprocals? Stick around to find out. Find the reciprocal, multiply by the reciprocal, divide by the reciprocal. But what is the reciprocal? If you have watched any of my other videos, you know I like to group new math concepts into one of two groups, explained and not explained. I think that some concepts have to be explained by a teacher, say the building blocks or base of what is stacked on top. You need to learn these explained topics before moving on to learn the not explained topics. The not explained topics, my favorite type of concept, is one that can be intuitively figured out through observing unique patterns. Reciprocals, however, as is multiplication, an explained type of concept. This means we can use reciprocals to help find patterns in the future. But for now, an explained comment means we need to start with the definition. In math, a reciprocal is a mathematical expression or function so related to another that their product is 1. Thank you, Google Definitions. To make our efforts more efficient and productive for the future, let us quickly remember this equation that 1 is equivalent to a number over itself, or x over x. We can prove this to be true because any number divided by itself is 1. Let us also remember that 3 is equal to 3 over 1. We can prove this equation because any number over 1 is itself. If we apply the definition of a reciprocal from before while exchanging 3 for 3 upon 1 and 1 for 3 upon 3, I think with knowledge on how to multiply fractions, it is simple to find the reciprocal of 3, and that it is 1/3. If you don't know how to multiply fractions and or how I suddenly got the reciprocal of 3, click here for a quick tutorial on how to do so. Before finding the reciprocal of another number I will give you, try to see if you can spot a pattern between a number and its reciprocal. Here I have a setup very similar to the previous slide, but now we have to find the reciprocal of 4. With a basic idea for multiplying fractions, I think we can notice by now the reciprocal of 4 is 1/4. Note that numbers equal to 1/4, such as 2 over 8, are also the reciprocal of 4, but 1/4 is the most simplified version. I hope we can know by now the reciprocal of 3 and 4, and by now I hope we have observed a pattern. If you did not and you would like to find out before I show you on the next slide, you may pause the video. For now, however, I will go on. If this is the pattern you have noticed, or a pattern similar to this one, then congratulations for you finding this. I hope we can apply this pattern we have noticed to finding the reciprocals of other types of numbers, such as fractions. Here, I have an improper fraction, or a fraction greater than 1, and I must find the reciprocal of this fraction. I know that a number multiplied by its reciprocal is 1, as discussed before. From the beginning of the video, you may remember me saying any number over itself is 1, one of the basic rules of division. Why I'm saying this is because I want to multiply 5 over 4 by something over something to get a multiple of 5 over a multiple of 4, but I want the multiple of 5 over the multiple of 4 to be the same, because any number over itself is 1. I guess a Cliff Notes version of my ramble is that I want to find a common multiple of 5 and 4. Let us make it the least common multiple for simplicity. I can find the least common multiple of 5 and 4 is 20. I know I can multiply 5 by 4 in the numerator, or the top half of a fraction, to get 20, and 4 by 5 to also get 20 in the denominator, or the bottom half of a fraction. Because 20 over 20 is equal to 1, we know that 4 upon 5 is the reciprocal upon 5 over 4. If we take what we know about the reciprocals of whole numbers, I hope we can see a potential pattern for reciprocals of fractions. Let us test this with another example of multiplying fractions. Using what we have done in the previous slide, I think we can figure out that the least common multiple of 3 and 5 is 15, finding the reciprocal of 3 upon 5 to be 5 upon 3. Remember, I am trying to find the least common multiple of both the numerator and the denominator, so I can get a number over the same number, which is also equal to 1, and is the product of a number and its reciprocal. By now, you should see if your theory about reciprocals of fractions was correct. If you wish to solve the pattern on your own, I suggest pausing, as I will go on to the next slide. For any fractions, this is how you would find the reciprocal. Remember, however, if you ever forget how to find the reciprocal of a number, remember the definition, but not the equation. It is more beneficial to walk through the steps every time and gain from it, rather than applying a meaningless equation you use only for a test. Note that we can find the reciprocals of improper fractions this way, so if there are any mixed fractions, which are a whole number plus a fraction, simply convert them into an improper fraction. I go over them in my multiplying fractions video, so look at that video if you are confused. There is one more concept to learn when finding reciprocals, and it is finding the reciprocals of decimals. Don't worry though, they are not as complex as they appear. From the definition, which we went over at the beginning of the video, we know a number multiplied by its reciprocal is 1. We also know how to find the reciprocal of fractions. Using our sense of logic, I think it is laid out that we can simply convert 0 and 3/10 into 3 upon 10, making our finding the reciprocal much easier. If you are confused why I converted 3/10 into 3 upon 10, it is because we know how to find the reciprocal of fractions, but not yet decimals. So converting a decimal to a fraction is much easier for us to find the reciprocal of decimals. This would be the reciprocal of 3 over 10, equivalent to 3/10. If you don't know how to convert decimals into fractions, it is not necessary for all reciprocal problems, but if so, it is for another video. This will be our last example of the video, converting 1 and 27/100ths into a fraction. First, we can see that the numbers past the decimal go back to the hundredth, so our fraction of 1 and 27/100ths will be 127 upon 100. We can find the reciprocal by swapping the numerator and our denominator using the pattern we found at the beginning of the video. Two last things about reciprocals. 1. A reciprocal is also known as a multiplicative inverse. Multiplicative inverse. It is very fun to say, but a reciprocal and a multiplicative inverse are synonymous to each other. Second, another way of asking what a reciprocal of a number is in number form is x to the power of -1. This is also known as the multiplicative inverse of x, or the reciprocal of x. Thank you for watching this video. If you have any specific math problems you want gone over, or math concepts, comment them below. Would you like more examples for practice? There are more in a Google document in the description. Ooh, the sunlight beating down on the very tall, a very majestic reciprocal tower.